quicker than the actual construction of space-time itself. It has the capacity to keep up with its consciousness of it. As a result, it will gradually take apart this thought, filling me with a feeling of disquiet. Right now, our night sky is quickly changing, and within the next few decades, perhaps sooner, it could become totally unrecognizable. Specialists, including Neil deGrasse Tyson, are sounding the alarm, perceiving the inevitable changes brought on by the shifting of Polaris. The foundational reason behind this change is shockingly startling. Polaris, commonly known as the North Star, has been a dependable fixture in the sky for a long time, serving as a critical point of reference for astronomers, pilots, and stargazers alike. However, this could soon change, altering the way we perceive the sky and study the universe. We should examine what this change could mean for us. For many years, Polaris has been a guiding light for mariners and stargazers, remaining firmly fixed in the sky. Its reliable presence has been crucial for navigation. Yet this stability may soon be disrupted. A paper from the esteemed Royal Astronomical Society, published in September 2023, raised concerns about the future of this celestial marker. Polaris is entering a volatile stage, one where it could potentially explode, vanishing from sight forever and reshaping the sky as we know it. Before considering the possible outcomes of this event, let's delve deeper into the characteristics of the star itself. Polaris is notable for its proximity to the celestial North Pole. Positioned directly above Earth's northernmost point, it appears nearly stationary in the sky. It resides in the Ursa Minor constellation, commonly known as the Little Dipper. Polaris shines with moderate brightness, resembling a yellow-white supergiant star that is much larger and brighter than our own Sunday. However, Polaris is not a single star. It is part of a complex triple-star system consisting of Polaris A and Polaris B as a binary pair, with a third star orbiting them. The gravitational forces between these stars influence their orbits and behavior. Disruptions in their interactions could cause shifts in their brightness or pulsation patterns. Yet, the exact nature of these forces is still not fully understood. Polaris is located approximately 323 light-years from Earth, meaning the light we currently see from it began its journey centuries ago. If Polaris were to explode, we wouldn't observe the effects for over 300 years. It's even possible that Polaris has already exploded, but we have yet to witness it. Throughout history, the North Star has held significant cultural, navigational, and symbolic importance. Its steady position has made it an invaluable guide for ancient mariners navigating across seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining unchanged in the ever-shifting sky. For astronomers, Polaris has been a crucial reference point in studying stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have offered vital insights into the properties of stars and the behavior of variable stars. This trait has also been key in measuring cosmic distances and calibrating scientific instruments. Recently, however, Polaris has begun to show signs of deviating from its usual behavior. This anomaly in its pulsation cycle has intrigued astronomers, prompting further investigation into the cause of these unexpected changes. Instead of adhering to its normal pattern, Polaris has started to exhibit irregular dimming, raising concerns that the star may be nearing the end of its life cycle. This behavior aligns with what is observed in stars that are approaching their final stages. The gradual increase in Polaris's pulsation period has been consistently tracked back to interactions within its star system. There has been an annual increase of approximately 4.5 seconds in the pulsation period. While this may seem insignificant, it carries profound implications. Some astronomers suggest that gravitational forces within the Polaris system may be driving these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that Polaris is entering a critical phase that could lead to an explosion. The similarities between the behavior of Polaris and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have exhibited complex variations in brightness, raising concerns that they may be nearing a dramatic explosion. Stars nearing the end of their life cycles often display such irregularities before their demise. NASA has expressed greater concern about Betelgeuse, but formal attention has yet to fully shift toward Polaris. As a Cepheid variable star approaches the end of its life, it undergoes several stages, including the red giant phase and, ultimately, a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict it has entered the stage of helium exhaustion, which is common for giant stars nearing their end. These inconsistencies align with patterns seen in stars nearing the end of their life cycles. However, definitive evidence of an impending supernova remains uncertain. Astronomers continue to monitor these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a spectacular event in the sky, possibly outshining the moon and remaining visible for days, weeks, or even months. Its brightness could drastically alter our view of key constellations, such as the Big Dipper or Ursa Major, where Polaris plays a pivotal role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes, due to its size and distance from us. The potential loss of Polaris, however, would have profound implications for navigation, astronomy, and cultural traditions. For centuries, Polaris has been a reliable guide for travelers and a foundational marker in celestial navigation. Mariners and explorers have depended on its fixed position to chart their courses. Its absence would necessitate a shift in how we approach navigation, requiring reliance on alternative stars or advanced technological systems. For astronomers, the disappearance of Polaris would mark the end of an era in stellar research. Its status as a Cepheid variable star has made it a cornerstone in the study of cosmic distances and stellar evolution. The insights derived from its pulsations have been instrumental in calibrating the cosmic distance ladder, a critical framework for measuring the vast scales of the universe. If Polaris were to vanish, it would force scientists to look to other Cepheid variables for similar research. While this is feasible, it would require adjustments and could slow the pace of discovery in certain areas of astrophysics. Culturally, the North Star has been a symbol of constancy, guidance, and hope. Its position in folklore, mythology, and art underscores its significance across civilizations. The loss of such a celestial icon would leave a void in the collective imagination of humanity, symbolizing the impermanence of even the most seemingly unchanging aspects of our universe. From a scientific perspective, observing a supernova explosion of a star like Polaris would provide an unprecedented opportunity for discovery. Supernovae are among the most energetic and dramatic events in the universe, producing vast amounts of light, heat, and radiation. These explosions create heavy elements, such as gold and uranium, which are dispersed into space, contributing to the formation of new stars and planets. The data collected from a Polaris supernova could offer invaluable insights into stellar life cycles, the physics of explosions, and the distribution of elements in the cosmos. Advanced telescopes and observational instruments would capture every moment of the event, enabling researchers to study its impact on nearby celestial objects and its aftermath in extraordinary detail. Despite the potential for scientific discovery, the uncertainty surrounding Polaris's future reminds us of the fragility and dynamism of the universe. Stars that seem eternal to us are, in reality, constantly evolving and subject to forces beyond our control. This inevitability underscores the importance of continued observation and exploration. As we deepen our understanding of stellar life cycles and cosmic phenomena, we prepare ourselves for the changes that lie ahead, both in the night sky and in our place within the universe. For now, Polaris remains a beacon of light in the northern sky, its steady glow a reminder of humanity's enduring curiosity and resilience. Whether it continues to guide us for centuries or becomes a brilliant supernova in the near future, its legacy will endure, illuminating both the heavens and the minds of those who look up at the stars. While the blast of Polaris could not be just about as outwardly awesome as creepy crawly juices, it might, in any case, be noticeable to the unaided eye for a drawn-out period, surpassing nearby stars. This would undoubtedly draw the attention of astronomers and observatories, creating boundless interest both in the scholarly community and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. But what will befall Polaris itself? What is its fate after a potential supernova blast? First, it's essential to note that while massive stars typically end their lives in a supernova blast, this isn't likely for Polaris. When a massive star undergoes a supernova, its core collapses, setting off a violent shock wave that causes the star to disintegrate. However, Polaris is not massive enough to go through such a catastrophic event. Rather, once it depletes its nuclear fuel, it will shed its outer layers and transform into a white dwarf. This transition won't lead to a supernova, but will result in a calmer end as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compressed core of a low to medium mass star that has spent its nuclear fuel. This remnant, although roughly the size of Earth, will still have the mass of the Sun. Once this process occurs, we will no longer observe Polaris as we know it. By comparing the effects of a potential Polaris blast with those of actual supernova events, we can gain valuable insights into the evolution of stars and their ultimate destinies. For example, supernova events like SN 1987A, SN 2011FA, and SN 2014J have provided significant data that help us understand what might happen to Polaris in the future. For instance, SN 1054 resulted in the formation of the Crab Nebula, a cloud of material that continues to expand and emit energy across various wavelengths, providing astronomers with a rich field of study. Additionally, SN 1987A, observed in the Large Magellanic Cloud, offered crucial insights into nucleosynthesis and the mechanics of supernova remnants, such as nebula formation and the release of high-energy radiation. These discoveries help us better understand the unique characteristics of Polaris. The formation of nebulae like the Crab Nebula occurs when material ejected during a supernova interacts with surrounding interstellar gas and dust, enriching the gas with heavy elements and contributing to the ongoing cycle of star birth and death. The release of high-energy particles and shock waves from supernovae also has significant implications for astrophysical processes and cosmic radiation. To make a definitive comparison, scientists are studying the differences in the composition and velocity of ejected materials between Polaris's potential blast and other observed supernova events. By analyzing light curves, spectra, and remnants from these events, they can predict the possible outcomes of Polaris's explosion. This research will help determine whether Polaris's blast could lead to nebula formation or significantly impact stellar environments. Another critical area of study involves the pulsational variability of stars nearing the end of their life cycles. By comparing Polaris with other supernova progenitors, astronomers hope to gain a deeper understanding of the mechanisms behind stellar explosions. Variations in pulsations in stars approaching death might indicate internal instability or an imminent catastrophic event, offering crucial clues about the processes leading to supernova blasts. Despite detailed observations and research, astronomers are still puzzled by the anomalies in Polaris's behavior. Understanding the causes behind these irregularities is essential for advancing our knowledge of stellar evolution. Investigating the factors causing Polaris's inconsistent pulsations requires collaboration across various scientific disciplines and the development of advanced models and observational techniques. The potential loss of Polaris as a stellar reference point raises key questions for astronomical research. Ground-based telescopes and measurements of celestial distances would require recalibration, which would affect the accuracy of cosmic measurements. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, emphasizing the significance of this event. The mysterious behavior of Polaris highlights the need for further studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and provide meaningful answers to determine the star's future. The study of Polaris and its eventual fate is more than an isolated investigation into a single star. It is a window into the broader processes governing stellar evolution and cosmic events. Polaris's irregular pulsations, for example, may offer clues about the internal dynamics of stars that are transitioning into their final stages. These pulsations are not only important for understanding Polaris itself, but could also contribute to our understanding of Cepheid variables, a class of stars crucial for measuring cosmic distances. If Polaris were to exhibit behavior leading to a significant event, such as a sudden change in brightness or a unique interaction with its environment, it could set a precedent for further studies. By comparing it with stars of similar mass and composition, researchers might uncover patterns that could be applied to other stellar systems, improving predictive models of star life cycles. Moreover, the disappearance of Polaris or its transformation into a white dwarf would have a cultural and historical impact. As the current North Star, Polaris has been a beacon for navigation and an anchor in the night sky for centuries. Its absence could prompt a re-evaluation of celestial navigation methods, potentially leading to innovative technologies that rely on other stellar or satellite systems. In the academic realm, the unique behavior of Polaris continues to fuel debates about the formation and evolution of stars. Researchers are increasingly looking at multi-wavelength observations, ranging from optical to X-ray and gamma-ray studies, to piece together the star's structure and composition. These studies aim to uncover the subtle interactions within Polaris that drive its variability and determine how such processes may relate to its future evolution. Another exciting avenue of research involves the potential role of binary companions. Polaris is known to have companion stars, and their gravitational interactions might influence its behavior. Understanding how these companions interact with Polaris could shed light on binary star evolution and their role in shaping the fate of stars nearing the end of their lifespans. In the long term, even after Polaris transitions to a white dwarf, it will remain a valuable object of study. White dwarfs serve as cosmic fossils, preserving information about the history of their progenitor stars. The study of such remnants could provide insight into the chemical enrichment of the galaxy, the formation of planetary systems, and the ultimate fate of our Sun, which is destined to follow a similar path. Polaris's journey from a pulsating variable star to a quiet white dwarf encapsulates the beauty and complexity of stellar life cycles. Its eventual fate will not only enrich our understanding of individual stars, but also enhance our comprehension of the larger processes that govern the cosmos. For astronomers and stargazers alike, Polaris's story serves as a poignant reminder of the dynamic and ever-changing nature of the universe.